Good, better, best. Never let it rest till your good is better and your better best. Welcome to Puerto Princesa Dream TV. We are on Quarter 1, Week 1 topic, so prepare your science notebook, pen, and calculator as we explore the world of force and motion, specifically the law of acceleration. I am Ma'am Danica, your science teacher broadcaster for today's lesson. At the end of this lesson, we will be able to 1. Explain how mass affects force and acceleration. 2. Investigate the effect of force to the motion of an object, considering the object's mass. 3. Calculate problems using Newton's second law of motion. If you are ready for our lesson, let's have a short pre-assessment to test your prior knowledge about our topic. Get your science notebook. Listen very carefully as I read the questions and options. Write the letter of the correct answer in your science notebook. Question number 1. What is the SI unit used to describe force? A. Newton. B. Kilogram. C. Meter per second. D. Meter per second squared. The answer is letter A, Newton. Question number 2. Which is the correct statement for the Newton's second law of motion? A. An object's acceleration depends on gravity. B. An object's acceleration depends on force only. C. An object's acceleration depends on mass only. D. An object's acceleration depends on both force and mass. The answer is letter D. An object's acceleration depends on both force and mass. Question number 3. What is the other term used to describe the Newton's second law of motion? A. Law of acceleration. B. Law of inertia. C. Law of interaction. D. Law of mass. The answer is letter A, Law of acceleration. Question number 4. When a heavy football player and a light one run into each other, who exerts more force? A. The light one. B. The heavy one. C. They are equal. D. There is no such thing as force. The answer is letter B, the heavy one. Question number 5. If you use the same force to push a truck and push a car, which one will have more acceleration and why? A. The car. It has less mass. B. The car. It has more mass. C. The truck. It has less mass. D. The truck. It has more mass. The answer is letter A, the car. It has less mass. What is your score? Did you get the correct answers? If yes, good job! If no, don't worry. We will deepen your understanding so you can get the correct answers at the end of this episode. Before we proceed to the lesson, let us unlock some terms that we will encounter later on. Acceleration. The rate at which an object's speed changes per unit time. Force. A push or a pull upon an object resulting from the object's interaction with another. Mass is a measure of the amount of matter in an object. It is usually measured in grams, g, or kilograms, kg. Motion generally refers to a change in the position of an object. In grade 7, you learned the different ways of describing the motion of an object in one dimension, like speed and acceleration. This time, you will learn to explain the motion of an object using Newton's laws of motion, specifically Newton's second law of motion. You will describe the relationship between the forces acting on an object in its motion due to these forces. Most of the motions we come across in our daily life are non-uniform, and the primary cause of changes in motion is force. Isaac Newton's laws of motion. In 1687, following 18 months of intense and effectively non-stop work, Newton published Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy, most often known as Principia. Principia is said to be the single most influential book on physics and possibly all of science. Its publication immediately raised Newton to international prominence. Principia offers an exact quantitative description of bodies in motion with 3 basic but important laws of motion. First law: a stationary body will remain stationary unless an external force is applied to it. Second law: force is equal to mass times acceleration and a change in motion. Example, change in speed is proportional to the force applied. Third law: for every action, there is an equal and opposite reaction. Newton's second law of motion. Let us now look into the situation where an unbalanced force or resultant force acts on a body. Push a chair. Does it move? In what direction does it move? Push the same chair harder. Does it move faster? When you push the chair, it will begin to move, or it will accelerate in the direction you pushed it. In the given example, where the mass of the object is constant, infer the relationship between force and acceleration. The situation can be summed up as follows. For a constant mass, or small letter m, acceleration, or small letter a, is directly proportional to the applied force. Mathematically, it can be expressed as A is directly proportional to F, where A is acceleration and F is resultant force. This time, imagine yourself applying the same amount of force, or capital letter F, to a chair and a table. Which one will move faster? A chair or table. Infer the relationship between the acceleration, A, and mass, M, if force is kept constant. The relationship between acceleration, or A, and mass, or M, can be summed up as follows. With a constant force, or F, acceleration, or A, is inversely proportional to mass, or M. Mathematically, it can be expressed as A is directly proportional to 1 over M. Combining the two expressions, you will get where K is the constant of magnitude. If K is equal to 1, then force is equal to mass times acceleration. Law of acceleration. The acceleration of an object is directly proportional to the magnitude of the net force acting on it and inversely proportional to its mass. This statement actually pertains to Newton's second law of motion or law of acceleration because it is concerned with the relation of acceleration to mass and force. This can be expressed in equation form as acceleration is equal to force divided by mass. This is often rearranged as force is equal to mass times acceleration, where for acceleration, the symbol is A and the unit is meter per second or can be simplified as meter per second squared. For force, the symbol is F and the unit is kilogram meter per second squared or Newton. For mass, the symbol is M and the unit is kilogram. Now, let us solve some sample problems with solutions for us to understand more about the lesson. Calculate the force needed to accelerate a 50 kg boy at a rate of 10 meters per second squared. First, let us determine the given. We have acceleration, which is equal to 10 meters per second squared, and mass, which is equal to 50 kilograms. How about our unknown? Our unknown is force. If force is our unknown, our equation would be force is equal to mass times acceleration. Based from this equation, let us substitute the given values, where mass is equal to 50 kilograms and acceleration is equal to 10 meters per second squared. So, 50 kilograms multiplied by 10 meters per second squared, the result would be force is equal to 500 kilograms meter per second squared, or we can say it as force is equal to 500 newtons. A 10 kilogram mass at rest on a frictionless table is acted upon by a constant force of 20 newtons, what is the acceleration of the mass? Our given values are mass is equal to 10 kilograms, while force is equal to 20 newtons. And our unknown is acceleration. The equation to be used if acceleration is unknown is acceleration is equal to force divided by mass. Based from the equation, let us substitute the given values. Acceleration is equal to force divided by mass. Force is equal to 20 newtons, while mass is equal to 10 kilograms. So, 20 newtons divided by 10 kilograms, and that is equal to 2 meters per second squared. A soccer ball kicked with a force of 13.5 newtons accelerates at 6.5 meters per second squared. What is the mass of the ball? Our given values based on the problem are force is equal to 13.5 newtons, while acceleration is equal to 6.5 meters per second squared. Our unknown is mass. Then, our equation would be mass is equal to force divided by acceleration. To solve for mass, substitute the value of force and acceleration. Mass is equal to 13.5 newtons divided by 6.5 meters per second squared. The answer is mass is equal to 2.08 kilograms. Newton's second law of motion, or law of acceleration, tells us that unbalanced forces produce acceleration. There are two factors that affect the acceleration of an object: the net force acting on the object and the object's mass. That is, acceleration is directly proportional to the net force and inversely proportional to the mass of the object. You can see the relationship among these variables by looking at the figure. By using this triangle method, you can also easily determine equations that will help you solve problems related to Newton's second law. To find for the value of the net force acting on the object, given the mass and acceleration, cover up the F symbol in the triangle by placing one of your fingers, then work out the operation that is left. So, the equation to use in finding force is equal to mass times acceleration. When finding for the value of object's mass, given the force and acceleration, cover up the mass symbol and work out the operation that is left. So, the equation is mass is equal to force divided by acceleration. Finally, to find the value for the object's acceleration, same process applies and you come up with acceleration is equal to force divided by mass. Learners, to fully understand our lesson for today, let's have a practice activity. Get your science notebook. Listen very carefully as I read the question and options. Write your answer in your science notebook. Problem: a hotel porter pushes a trolley of luggage. A net force acting on the trolley causes it to accelerate. What happens to the acceleration of the trolley if the magnitude of the net force is increased? Choose the correct answer. The acceleration of the trolley increases if the magnitude of the net force is increased. The acceleration of the trolley is directly proportional to the magnitude of the net force when the mass is constant. Or, the acceleration of the trolley decreases if the magnitude of the net force is increased. The acceleration of the trolley is inversely proportional to the magnitude of the net force when the mass is constant. The answer is the acceleration of the trolley increases if the magnitude of the net force is increased. The acceleration of the trolley is directly proportional to the magnitude of the net force when the mass is constant. I hope you got it right. Give yourselves a round of applause if you got it correctly. If not, let's proceed to the next activity for you to understand more about the lesson. Let's go! Now, let's do another activity. 1. It is easier to push an empty shopping cart than a full one because the full shopping cart has more or less mass than the empty one. This means that more force is required to push the full shopping cart. The answer: it is easier to push an empty shopping cart than a full one because the full shopping cart has more mass than an empty one. This means that more force is required to push the full shopping cart. 2. If you use the same force to push a wooden table and push a plastic chair, the plastic chair will have more or less acceleration than the wooden table because the plastic chair has less mass. The answer: if you use the same force to push a wooden table and push a plastic chair, the plastic chair will have more acceleration than the wooden table because the plastic chair has less mass. The answer: a car moves faster than the truck because according to Newton's second law of motion, acceleration is inversely proportional to mass. Have you gotten all the correct answers? Very good! Because we are done explaining all the information you need, let us proceed in synthesizing our lesson. 1. Newton's second law of motion is also known as the law of acceleration. 2. Newton's second law of motion says that when an unbalanced force is applied to a mass of an object, it causes it to accelerate. 3. The greater the force that is applied, the greater the acceleration. The lesser the force that is applied, the lesser the acceleration. 4. If the same force is applied to an object with a large mass, it will have a lesser acceleration. If the same force is applied to an object with a small mass, it will have a greater acceleration. And now that we are done with all the activities, let's assess your progress, learners. Question number 1. Which is the correct statement for the Newton's second law of motion? A. An object's acceleration depends on gravity. B. An object's acceleration depends on force only. C. An object's acceleration depends on mass only. D. An object's acceleration depends on both force and mass. The answer is letter D. An object's acceleration depends on both force and mass. Question number 2. What is the SI unit used to describe force? A. Newton. B. Kilogram. C. Meter per second. D. Meter per second squared. The answer is letter A, Newton. Question number 3. When a heavy football player and a light one run into each other, who exerts more force? A. The light one. B. The heavy one. C. They are equal. D. There is no such thing as force. The answer is B, the heavy one. Question number 4. What is the other term used to describe the Newton's second law of motion? A. Law of acceleration. B. Law of inertia. C. Law of interaction. D. Law of mass. The answer is letter A, law of acceleration. Question number 5. If you use the same force to push a truck and push a car, which one will have more acceleration and why? A. The car. It has less mass. B. The car. It has more mass. C. The truck. It has less mass. D. The truck. It has more mass. The answer is letter A. The car. It has less mass. Now, for your assignment, please have an advanced reading on Newton's third law of motion and answer the following in your science notebook. 1. What is Newton's third law of motion? 2. Does force always come in pairs? On our next video lesson, we are going to discuss the specifics of Newton's third law of motion. Congratulations, grade 8 learners! You learned about the law of acceleration. If you have questions, you may ask the assistance of your teachers. Nelson Mandela said, It always seems impossible until it's done. Once again, I am Ma'am Danica Grace P. Hilongos, your teacher, broadcaster, or partner. See you in the next episode, only here in Puerto Princesa City Dream TV.